right, I did want to take an opportunity to teach one more factoring method to you that isn't in your textbook, and it's a little bit more obscure, so not on the test. That's why I'm putting this optional video up after the test, but something a little extra that is there, because I've told you in the past, you cannot factor a sum of squares. And to an extent that's true. There are some sums of squares, though, that through a rather unorthodox method of factoring, you can break into simpler parts. So the last factoring method, and again, this isn't tested, which is why this lesson's optional here, is to create a PST, to create a difference of squares. Create a PST, let's say to form a difference of squares. And what this essentially means is what you have isn't anything, but you can make it something sometimes. For instance, write this down in your notes. We've got an a to the 4th, positive 10, a squared, positive 49. Now on the surface, you look at this and you might be thinking, hey, that is a PST, right? Perfect square, positive, even, right? And so you'd say, well, binomial squared, I got a square root of the first, square root of the last, plus sign here. And of course, we always do the multiply and double just to check. Wait a second. 7a squared doubles 14a squared. Oh, it's not a PST. So what we would have done in the past is, well, forget that then. Let's do backwards FOIL, right? A squared, signs are the same. And the only ways to split a 49 are 1 and 49 or 7 and 7. Well, 7 and 7 takes you right back here. 7 and 7 gives you an outer inner of 14. The 49 and 1 gives you an outer inner of 50. You can't factor this. Or can you? Here's the thought. If it looks like a PST, but it ain't quite a PST, and if the backwards FOIL method's not available, in some rare instances, you can make it a PST. Because after all, what number do I want to be here? A 14, right? There, now it's a PST. See how easy that was? And now we can, no, you can't do it quite like that. How do you turn a 10 into a 14 properly? You would technically add a 4a squared to it, wouldn't you? But you know, well, that's changing the problem, Mr. Nadaski. You can't add a 4a squared to that, you're right. Unless I also subtract a 4a squared from that. Now notice what I did. I added 4a squared and subtracted 4a squared. Technically, I've added nothing. I have not changed the problem. But I've changed the way it looks. I've got a PST here, and because what I added was a square, then what I subtracted is also a square. And notice that I now have a difference of squares when I factor the PST into the binomial squared. And now, difference of squares, of course we know that factors into a sum and difference. Put my plus, put my minus, a squared plus 7 here, a squared plus 7 here, and then the 4a squared splits into 2a and 2a. And just to make it look good, we'll go descending order, a squared plus 2a plus 7, a squared minus 2a plus 7. And that's how a to the 4th plus 10a squared plus 49 factors into a pair of similar trinomials. Now again, this is off the wall, right? This is really creative stuff we're having to get into. But again, it's Algebra 2. This is my last chance to show any of this kind of stuff to you. So I wanted to show you how some unfactorables in some instances can be made to factor if, by adding a perfect square to make it factorable, you then also subtract the perfect square, which, when you form the binomial squared, gives you a difference of squares. And then you can go from there. Write this example down now, if you would. X to the 4th, negative 21, x squared, y squared, positive 36, y to the 4th. As I look at this, I know it's not a PST. I don't have an even there in the middle, right? So I already know it's not a PST. But maybe I'm thinking backwards FOIL, right? So I'm like, okay, x squared and x squared, signs are both going to be the same, they're both going to be negative. Now, I know it's not 6y squared or 6y squared, right? That's impossible, because 6 and 6 doesn't give you 21. But maybe 9 and 4, no, that's 13. 18 and 2, it's 20, but not quite 21. And 3 and 12, 1 and 36, it doesn't factor, right? Well, this is one instance where maybe we can make it work. What we want to do is say, well, if it were a PST, I'd make it a binomial squared. And if it were a PST, I'd take the square of the first, I'd take the square of the last, and I'd take the sign of the middle. If it were really a PST, this is what it would factor into. But if it were a PST, then my middle number wouldn't be a negative 21. For it to be a PST, what would my middle number have to be? Multiply and double. Yeah, this would need to be a negative 12. Well, you can't just arbitrarily change a negative 21 into a negative 12. What do you have to do mathematically to go from negative 21 to negative 12? Add a 9x squared y squared to that. That would make it a negative 12. But if you add it, you also have to subtract it. For instance, if I just randomly, went up to Gavin, all the way in Japan, and I randomly gave Gavin 50 bucks, and I'd be like, oh, teacher's pet, oh, something doesn't look right here, he must have dirt on Mr. Nadaski. But then if I go take the 50 bucks right back, which gets very expensive, all this overseas flying, but if I take the 50 bucks right back, now Gavin's very confused at this point by what's going on, why is he giving me money, why is he taking it back? But really, truly, has anyone in the class somehow got money from Mr. Nadaski? No, nothing's changed. He's no richer nor poorer than he was before I gave him the 50 bucks and took it back. So we're adding the 9x squared, but also subtracting the 9x squared. And here's the key, that I'm subtracting a perfect square. Because a binomial squared is obviously a square, and I'm subtracting a perfect square, which means I have a difference of squares, which means it can factor into a sum and difference. We'll have our x squared minus 6y squared plus 3xy, and x squared minus 6y squared minus 3xy. Again, it's x squared minus 6y squared squared, so there's two of them. One of them here, one of them here. This has to split right down the middle, 3xy, 3xy. And of course, again, we'll just move the 3xy to the middle and the negative 3xy to the middle to get our final answer, x squared, positive 3xy, negative 6y squared, times x squared, negative 3xy, negative 6y squared. And there are my two similar trinomials that factor to give me the original x to the fourth, negative 21x squared, y squared, positive 36y to the fourth. And if you doubt me, triple distribute and check it out. It works exactly to that. One more example I want to show you, and then I want you to try one on your own. And this is the example I started by mentioning, a sum of squares. Sum of squares doesn't factor, Mr. Nadaski. Most of the time that's true, but this is a special sum of squares. I'm going to imagine for just a moment that rather than a sum of squares, it's a perfect square trinomial with an invisible middle term. And if it is a perfect square trinomial with an invisible middle term, I just don't know what it is, then I could factor it into a binomial squared. What would the binomial be? Write it down on your paper. Did you write b squared plus 8? I hope you did. Now, if that's true, what would the invisible middle term have to be for this to actually be accurate factoring? Multiply and double. Yeah, it'd have to be a 16b squared, but you notice I just randomly inserted a plus 16b squared. You can't randomly insert something unless you also take it away. And I'll just bring that term right down here. So that would be entire newly formed PST factors into the binomial squared. And the extra term that I had to subtract just comes down. And yup, you guessed it, difference of squares, sum and difference, b squared plus 8 plus 4b, b squared plus 8 minus 4b. And as a last step, we'll pull the 4b's to the middle. So it says b squared plus 4b plus 8, b squared minus 4b plus 8. And that's how you would factor b to the fourth plus 64, a sum of squares that does factor. Now I want to point something out. In each case, fourth power is present, right? Because without a fourth power, or an eighth power could work as well, the middle term you're shooting for wouldn't have a square in it, right? So you'd have to have a fourth power present. Also, the other number has to be a square already. The trail number has to be a square. And then, again, what you have to do to the middle term, or in this case, the middle term you'd have to create, has to be a square also that must be added. You can't subtract anything from the middle term, because then you'd have to add on the back end, which wouldn't give you a difference of squares. So the key is that something was added, something was added, something was added, which was a square, so on the back end I'm then subtracting a square. So again, does this always work? No. Frankly, it doesn't work very often, but you know, it's there. All right, so I'm going to give you a chance to try just a couple of these on your own after you've tried them, and give it a good effort. Give it a good effort, see if you can get them. When you get to the end, either you get it and you think you got it right, or you're like, I can't figure it out. Okay, then continue the video. But after I write these up, I want you to pause the video and spend a few minutes working on these. And tell you what we'll do on your next quiz. I'll give you a bonus question that includes one like this. Not these exact problems, but one like this. All right, go ahead and pause the video and work. All right, well, let's see how you did. If you feel like you got it, props to you. If you ended up getting it, I want you to email me and let me know. Hey, I nailed this problem. I want to know about that. So hopefully you said, well, it's not a PST. I know that, right? Because when I tried to make the binomial squared, I had a 3x squared, I had a 4y squared, and a positive. But multiply and double, I should have had a 24. Well, to get that, I'm going to add 4x squared y squared. Boom, now it's a 24. Now I'm correct. I'm done. Except I also have to subtract 4x squared y squared. And so I also have to write that down here as well. And then you say, well, this is a difference of squares. So I'm going to get a sum and a difference. I'm going to get a 3x squared plus 4y squared. And I'm going to get another 3x squared plus 4y squared. And then because it's a sum and difference, I'm going to have plus 2xy. And I'm going to have a minus 2xy. Now, did you notice what I did when I wrote the answer? Because I'm lazy, I split it. Instead of copying it together at the beginning and then putting the plus and minus, I split it and dropped the plus and minus in the middle, so I didn't have to rewrite it. If you got this answer on your own, I want to know about it. Now, there's not extra credit for you, but it definitely lets me know you may be someone who gets some extra credit on the next quiz, and hey, I'll be proud of you. All right, let's take a look at the next one. And clearly no PST. But just imagine for a moment that there's a term in there. You just can't see it. Perfect square trinomial would be square root of the first, square root of the last, sine of the middle, squared. But if that were true, the middle term multiplying double would have to be a 36a squared. Well, if you put a 36a squared in there, you also have to subtract a 36a squared. And there's my difference of squares. Sum and difference. We're going to get a 2a squared plus 9 here and a 2a squared plus 9 here. Then we're going to take the square root and put plus and minus. Plus 6a minus 6a. But I'm going to put them in the middle. Plus 6a minus 6a. And there's my answer. Same thing. If you got that right all on your own, I want to hear about it. Let me know that you nailed it. Now, there is something just a little unusual that can happen that I want to show you because it can be kind of discouraging, perhaps. Write this one down if you would. 9m to the 8th minus 19m to the 4th n squared plus 25 n to the 4th. By the way, remember me saying 4th powers or 8th powers needed, so the middle term is actually a square, has a square or 4th power or something to it. Well, that's what we have here. Well, again, just working on my own, binomial square, I got 3m to the 4th here, I've got a 5n squared here, sine of the middle is negative, so multiply and double, I want a negative 30, right? Well, I don't have a negative 30, do I? How do I go from negative 19 to negative 30? Subtract 11m to the 4th n squared, or put a negative 11? Well, that means I'd have to put a positive 11m to the 4th n squared. Oh, yeah, this one's not going to work out. Well, correction. Normally, we would keep the sign in the middle, but keeping it doesn't help, right? What if instead of a negative right here, would have said, well, how about a positive? If I had a positive right here, what would be my target number? My target number, pardon the interruption, wouldn't be a negative 30. If this were a positive, my target would be a positive 30. What would I have to do to negative 19 to get a positive 30? Well, I'd have to add 19 just to get to 0, and then 30 more to get to 30, right? I'd have to add 49m to the 4th n squared. So there are maybe times you have to go with a different sign than what's here just to make it work. Because, yeah, if I add 49, I'm good. Because I can then also subtract 49m to the 4th n squared. And now I can factor the rest of the way. I've got my binomial, my sum and difference. I've got a 3n to the 4th plus 5n squared, 3n to the 4th plus 5n squared again, because there were two of them. And I'm going to put my plus 7m squared n and minus 7m squared n in the middle. And there's my answer. Let me make sure that all made it on the camera. And it did. Let's zoom in just a little bit more there for you. Again, this isn't tested, so if this just totally blew your mind, be thankful it's not tested. But if you're like, hey, I think I got this, good. Be on the lookout for a bonus problem on your next quiz that has this type of thing on it. All right, trust you'll have a great weekend, or whatever it is that you watch this video, and looking forward to teaching you as we start our next chapter, or next section after this test. We'll start getting into fractional or rational quantities and radical quantities. That'll be our next major concept we'll spend some time on here in Algebra 2. Have a great day.